My name is William Michael. I'm the headmaster of the Classical Liberal Arts Academy, and when I was in high school, I really didn't know what I was doing. I didn't have good teachers. What we studied in school didn't make much sense, and I really didn't know how I was ever going to use the stuff that we were asked to study in school. And as a high school student, you may be struggling with these sorts of questions too. And I want you to know that it's not your fault. I'd also like to ask you to think differently about your high school studies. Sometimes we ask, why do I need to study this? And that's especially true of a subject like algebra. We ask, why do I need to study algebra? How am I ever going to use algebra? And teachers often try to give us some helpful explanations or examples of how we're going to use algebra. But if we really asked our teachers, when do you use algebra in your everyday life? They would have to admit, if they're honest, that they really don't use algebra because it's really not true. I'd like to suggest a different goal in studying algebra as a high school student. I'd like to recommend you simply say this: I am going to study algebra because it's required for my high school diploma. I'm going to study algebra because it's required for my high school diploma. And I am going to use my high school diploma, that's for sure. Because my high school diploma is useful, algebra is useful, and I'm going to study algebra for the sake of my high school diploma. And let that be your answer, because that's actually a good answer. What I'd like to do is help you to complete high school algebra. In this course, we're going to study Algebra I, or Elementary Algebra. It's a difficult study because for most of us, we're not going to use it. We don't see it in use in everyday life, and so there's not much motivation to study it. What's important is that we study it and get it done because we need to get our high school diploma, and this course is required. So I'd like to challenge you again to think about it differently. Let's just work through this textbook. Let's study algebra so we can complete high school algebra and finish the requirements that are needed for our high school diploma. I'm going to walk with you through this textbook. I'm going to make videos that last about an hour. They're not going to be exciting. They're not intended to entertain you. They're intended to help you finish algebra so that you can move on in your high school studies and earn your high school diploma. So let's just go ahead and get started with our first lesson in Algebra I. We're going to skip down to page 17. Here you can see that the goal of Chapter 1 is to set a foundation for our study of algebra. Down in the introduction we read, just like a building needs a firm foundation to support it, your study of algebra needs to have a firm foundation. To ensure this, we begin this book with a review of arithmetic operations with whole numbers, integers, fractions, and decimals, so that you have a solid base that will support your study of algebra. So if you're studying Algebra I in 9th grade or whatever grade it may be, you may look back at your years of studying math and say, well, I never really understood this, I never really understood that, and I'm not sure if I can continue into a more difficult study like algebra. You can use this first chapter to help you review and clean up any areas of your arithmetic knowledge that might not be clear. So we're just going to walk through this. Some of this stuff might be considered easy. It might be baby work for you, but some of it you might find helpful. So you can skip ahead if this is all easy, but I recommend that you not assume that you know more than you actually do, because remember, the purpose of this chapter is to lay a firm foundation for the study of algebra. So I'd recommend you study through the chapter, make sure you understand everything that's there, and let the assessments determine whether you really understand it or not, because you might think that you understand something that you're really just familiar with, but you really don't understand it, and that may come back to cause trouble later in your study of algebra. So let's just work through this first section. You can see here there's a chapter outline, and there's 10 sections in the chapter. In this video, we're just going to walk through section 1, Introduction to Whole Numbers. We're just going to take our time and walk through section 1. It's actually quite long. There's a lot of content in this section, but the purpose of this video is just to help you through it. Now, in order to earn a high school credit for algebra, you need to complete 120 hours of instructional time. 120 hours of instructional time. That's the amount of time that students spend in a high school algebra class. I'm going to provide videos that provide that amount of time for you. So what I ask you to do is simply work through these videos, follow me as I go through the content, have a notebook open to jot down any notes that you think would be helpful along the way, but use these videos to fulfill the time that's required for you to complete this high school course. You need 120 hours. So if I make videos that last 1 hour, as boring as they may be, if you can discipline yourself to work through them, you can complete the time that's required for you to put Algebra I on your high school transcript. That's the goal. We're studying Algebra I for one reason, so that we can earn our high school diploma. Keep it simple, and you won't get discouraged. So let's get started here with section 1, section 1.1, I should say, on an introduction to whole numbers. Now, in each section of the textbook, you'll see there's objectives. That means these are our goals for studying this section. These are our goals. By the end of this section, you will be able to use place value with whole numbers. You'll be able to identify multiples and apply divisibility tests. You'll be able to find prime factorizations and least common multiples. Now, at the beginning, you might not even know what that means, but at the end of the section, you'll understand these things and you'll be able to do them. And so that'll be a good test for your study as we move forward. Let's see if by going through this chapter, we can learn to do these 3 things. So let's go ahead and get started. We're going to skip down to this next page here. We're going to learn to use place value with whole numbers. Use place value with whole numbers. Now, again, I know that this stuff can be very boring. I remember when I was in high school, this was the last thing on earth that I wanted to do. But we have to complete these studies to earn our high school diploma. And there's a lot of vocabulary that we're going to have to learn. We're going to learn lots of new words, strange phrases, and that's going to be the biggest challenge in algebra. So let's just make sure that we understand what phrases mean. We want to understand what place value means, and we also want to know what whole numbers are. Then we can understand what it means to use place value with whole numbers. Let's go ahead and read this. The most basic numbers used in algebra are the numbers that we use to count objects. And you see just the simple counting numbers, 1, 2, 3, 4, and so on. These are called counting numbers, the numbers we count with. Very simple. Counting numbers are also called natural numbers. If we add 0 to the counting numbers, we get the set of whole numbers. And we see them listed here. Counting numbers and then whole numbers. They're the same as counting numbers with 0 added. So when we look back up to the title of this section, using place value with whole numbers are numbers beginning with 0 that include all of the counting numbers. So 0, 1, 2, 3, 4, and so on. These are whole numbers. We then learn that we can visualize or we can illustrate counting numbers and whole numbers using a number line. And you can see the term number line is in bold print here because it's an important vocabulary term. Number line. And you'll see this in tests. You'll see this in your grade level tests, maybe on the SAT. You'll see this illustration of a number line. You see it's a straight line with arrows on each end going in opposite directions. And you see numbers written along the number line. This line illustrates the quantity, the value of numbers. If we start on the left and move to the right, the value of the numbers goes up. The numbers get larger as we move from left to right. That's what this arrow is showing you here. It's showing that as we move to the right on the number line, the numbers get larger. If we start on the right and move to the left, the numbers get smaller. And again, that's what this is showing you right here. If we move from right to left, the numbers get smaller. If we move from left to right, the numbers get larger. Pretty simple. But at this point, you should understand what whole numbers are, counting numbers, and the number 0. And you should understand what a number line shows us, because you'll see this on tests in the future. Now moving on, we're going to learn about place value, because we saw in the title of this section, use place value with whole numbers. We know what whole numbers are now. Now we need to learn what place value is. And we see this chart. We read, our number system is called a place value system. Our number system is called a place value system because the value of a digit depends on its position in a number. The value of a digit depends on its position in a number. Now this chart here shows us, look at the top, it shows us place value. So getting back to the title here, use place value. So this is showing us what place value means. We want to understand what place value means. And we read, the value of a digit in a number depends on its position. So down at the bottom of this chart, we see this number, 5278194. And we might wonder, what does that number mean? Well, each of those numbers is a digit standing in a different position or different place. And each place has a different value. That's what place value means. In this chart, all of the different places are labeled here. We see that the first place on the right is the ones place. The second place is the tens place. The third place is the hundreds place. Then we have the thousands place, the 10,000s place, 100,000s place, millions place, and so on. And this can go on forever. But we start on the right with the ones, and we move to the left. And the place value increases as we move to the left. So it's the opposite of what we just saw on the number line. Don't get those confused. So this first number 4 stands in the ones place, and it tells us that there are 4 ones in this quantity. We then see that there are 9 tens. 9 tens is equal to 90. 9 tens and 4 ones makes 94. We then see that there's 100 in this quantity. So we have 100, 9 tens, and 4 ones, or a total of 194. We see there are 8 thousands, 7 10,000s, 200,000s, and 5 millions. So each of the digits in this number stands in a different place and has a different place value. That's what place value means. So getting back up here, we see use place value with whole numbers. We want to learn how to read and write numbers using our number system, using place value. Now, again, you may find this very easy. You may say, give me a break. This is baby stuff. That's good. Fine. But some of you may just, not understand some part of this, so it's good to review. We want to build a good foundation to study algebra. And believe it or not, even though many students might look at this and say, oh, this is so simple. This is baby stuff. Often the problems that we get wrong in higher math, in algebra, and so on, the problems that we get wrong are actually caused by simple errors in things like place value. So we've got to learn to be very careful, because the order of the digits in a number, making sure that everything is in the right place, is actually very important in our number system. So we've got to be careful. So down here we have an example. We're given a number, 63,407,218. And we're then given a number of different digits, and we're asked to identify what place value that digit stands in this number. So the first one, letter A, we're given is 7. And if we look at the number, we see that 7 stands here in this fourth place. So we have 1, 2, 3, 4 places from the right. The number 7 stands in the fourth place. So if we look up here to the chart, 1, 2, 3, 4, we see that that 7 stands in the thousands place. So that's the place value of that digit, of the 7. The place value is thousands. The second digit they ask us to identify is 0. And if we look, we see that 0 is standing in the fifth place from the right. So if we look over here and say the first place, second place, third, fourth, fifth, 0 is standing in the 10,000s place. 1 is standing in the second place, which is the tens. 6 is standing in the 8th place, which if we count 1, 2, 3, 4, 5, 6, 7, 8 is the 10 millions. So there are 6 10 millions. And then lastly, 3 is standing in the 7th place, which is millions. 3 millions. So we've identified the place value for each of these digits. That's what it means to use place value with whole numbers. So the first challenge that we have is to make sure that we can accurately read a number in our number system. We have to learn how to read it, and we're going to make sure we understand how to do that in just a minute. We need to know how to accurately read numbers in our number system. And we can't make mistakes. So you can say, again, this is easy. Understanding the idea may be easy, but we've got to make sure we never make mistakes when we do these things. We've got to make sure that we can accurately read these numbers every single time we read them. And we've got to understand place value in order to do that. Now, below that exercise, we simply see the solution that we already talked about. And we see that all of our answers were correct. And what they tell you to do is to take that number and write it into the place value chart and use that chart to help you identify the place value. So when you see numbers written out like this, you need to always think of them as being in this place value chart so that you can read them correctly. Here, you're given 2 more examples to try, which you might want to test yourself on, but we're going to skip them in our video. If you have any questions about any of these things, or if as we go through this, there's some topic that you just don't feel like you understand, or it's still confusing, You can get in touch with us anytime. You can email us or chat with us, and we'll help you with any problems you have. But you can try those exercises for yourself, see how you feel about them, and if you need more help, get in touch and we'll help you out. Let's go on here, and we're going to learn how to name a whole number in words, or how to read a whole number. We read here in the textbook, when you write a check. Now, this is one of these silly examples that really isn't very helpful in a math class. I doubt that many of you are ever going to write a check. I'm 49 years old. I am a father, head of a household, a business owner, and I might write 2 or 3 checks every year. We hardly ever write checks anymore, so this isn't a very helpful illustration. You might actually need to ask one of your parents to show you a check, because you may have never even seen a check. We don't use checks very much anymore. But our textbook here uses check writing as an example. When you write a check to pay someone, you write out the number, the amount of money that is, you write out the number in words as well as in digits. So when you write out a check, you actually write the number out in words, and then you also write it in digits. So we need to understand how to do both. To write a number in words, write the number in each period, followed by the name of the period. Now, I'm not sure that the book explained what a period is. So let's go back up here a minute and make sure we understand with a period. I may have just skipped it. If we look at the place values, all of these different columns, if we look to the top, we'll see that each of the 3 columns is joined together and given a name. So these first 3 columns, these first 3 places, are all together called ones. So if we have the number 218, it's 2 hundreds, 110, and 8 ones. But we can read that number in a period and say there are 218 ones, or 218 units. So the first period consists of these first 3 columns. This is called the ones period. The second period is called the thousands period, and it's made up of thousands, 10,000s, and 100,000s. This is the thousands period, 3 columns. Then we have the millions period, the billions period, the trillions, and so on. So each 3 places is called a period. And what we're taught here is to start at the left. To write a number in words, write the number in each period, followed by the name of the period, without the S at the end. Start at the left, where the periods have the largest value. The ones period is not named, so at the end of the number we don't say ones. These commas separate the periods, so wherever there is a comma in the number, put a comma between the words. And we're given an example, and this is easier just to see in an example. We're given this number 74, 218, 369. So we can see the first 3 numbers are separated by a comma from the next 3 numbers, and then there's another comma before the last 2 numbers on the left. We can read this as 74,218,369. 74 million. So we read the numbers with the period name, millions, but we drop the S off. That's what this tells us right here, without the S at the end. 74,218,369. And we write that as 74 million, comma, to separate the periods, 218,000, comma, to separate the periods, 369, period. So in this paragraph here, we have to make sure that we understand how to read and write numbers in our number system. If you can do this easily, great. If you struggle to understand this or really don't know how to do this, like I said, you should just get in touch with us and ask for some more help. We're happy to help you. But you've got an explanation down here that shows what I just explained, and even more importantly, you've got a set of rules here. 3 steps to help you name a whole number in words. So this is a summary of what we've just learned up here. How to name a whole number in words. How to name a whole number in words. So if we see a number written like this, a big long number, or up here this long number, how do we read it? How do we read a number like this? Step 1, start at the left. Start at the left, on the left side of the number. Name the number in each period. Now notice it doesn't say name the number in each place. It says name the number in each period. So if we start over here, we see that the 6 and the 3, 63, tell us how many millions there are. So we start by saying 63 million. Then we see 407. That tells us how many thousands there are. 63,407,000. And then 218 tells us how many ones are left. 63,407,218. So we start at the left, name the number in each period, followed by the period name. We put commas in the number to separate the periods, and we do not name the ones period. So that's how we name a whole number in words. And then you're given an example here where you're given a long number, a very great number, and you're asked to give the name of this number using words. And so what you would need to do is put this number into that place value chart so you can see what period each number is in. And then starting at the left, you can read that number. We're shown how to do that down here in the solution. So the number is written out, and the periods are listed here in blue. So we start at the left, and we can read 8,165,432,098,710. 8,165,432,098,710. That's how we would read that very great number following these steps given to us in our lesson. And you're given 2 more examples here that you can try, and I'll leave you to try those on your own. Now lastly, we're given another rule down here, and these rules are very helpful. If there's something you're going to focus on, I would tell you to focus on 2 things. First of all, vocabulary items that are printed in bold. We saw on the first page these bold printed terms. Those are your important vocabulary items: counting numbers, whole numbers, number line. Make sure you learn the vocabulary. And the second important thing is to make sure you learn rules, like we learn here how to name a whole number in words, and down here how to write a whole number using digits. So vocabulary items and rules are very important for you to learn. So if you're taking notes, if you're wondering, what should I write down? What should I take note of? What should I maybe memorize? You should memorize the meaning of bold print words in the textbook. Those are your important vocabulary items. And you should make sure that you learn any rules that are taught in the textbook. A lot of the rest of what's in the book is just going to be explanations and examples. So you can work through the examples and read the explanations, but you should really be careful to learn the vocabulary items and the rules that are included in the text. So let's learn here how to write a whole number using digits, and we'll see an example down here. Step 1, identify the words that indicate the periods. So we're assuming that you have someone read a number to you, and you have to write that number down using numerals, using digits. The first thing you need to do is identify the words that indicate the different periods, because we're working backwards now. We're being told the words that name the number, and we've got to write that number down. So the first thing we need to do is identify the words that indicate the periods. Then draw 3 blanks to indicate the number of places needed in each period. Separate the periods by commas. Then name the number in each period and place the digits in the correct place value position. So there's the steps for our rule, and down here we're given an example. So we're told this number in words. Write the number 9,246,073,189 as a whole number using digits. So we're asked to write this number using digits. Now, step 1 tells us to identify the words that indicate periods, and we can see them: billion, million, thousand, and then we have ones at the end. So we can see the periods that are given. Draw 3 blanks to indicate the number of places needed in each period. So down here you can see that they've done that. You can see that they wrote billions for the first period, and they drew 3 blank spaces. Then they wrote millions, and they drew 3 blank spaces. Thousands, 3 blank spaces, and ones, 3 blank spaces. We're then told to separate the periods by commas, and you can see that they've done that. In between each period, they've placed a comma. And then the last step, name the number in each period and place the digits in the correct place value position. So for the first period, we have 9 billion. And you can see in the billions period, they wrote the number 9. Then there's 246 million. So in the millions period, they wrote 246. We then see that there's 73,000. So in the thousands period, they wrote 73. Notice they put a 0 in the empty place because there are 0 hundred thousands. There are 73 thousands. And then lastly, we see 189 at the end of the number. That tells us how many ones there are. And so in the ones period, they wrote 189. And then lastly here, they give the answer written out as it should be written. 9,246,073,189. So this shows us how to use place value in whole numbers. How to use place value in whole numbers. And if we go back up to the top, bear with me as I scroll here. If we go back up to the top of this lesson, we remember the title was How to Use Place Value with Whole Numbers. And that's what we've just learned to do. So let me scroll back down to the bottom here. All right, so continuing, we've got an example here that's going to try to show us how this is useful. So let's read this example. In 2013, the U.S. Census Bureau, that's a department of the government that collects information from the people. So they send out these questionnaires that ask the American people for all kinds of information about their families, their businesses, their lives in general. and it collects all of this information so that the government can understand important things about the American people. In 2013, the U.S. Census Bureau estimated that the population of the state of New York is 19,651,127. We could say the population of New York was approximately 20 million. So if we had this number, 19,651,127, if someone asked us how many people live in New York, we wouldn't necessarily want to use this number, especially when we consider that people are being born and are dying all the time. So we never really have an exact number about how many people are living anywhere. So normally we want to estimate. If we were asked how many people live in New York, we could say, well, there's about 20 million. About 20 million. And that would be a good approximation for this number. In many cases, you don't need the exact value. An approximate number is good enough. The process of approximating a number or estimating a number is called rounding. We round off a number. Numbers are rounded to a specific place value, depending on how much accuracy is needed. Saying that the population of New York is approximately 20 million people means that we rounded to the millions place. So we looked at this number, 19,651,127. And if we say, how many people live in New York? And we say, 20 million or so, around 20 million, we're rounding to the millions place. If we wanted to be a little bit more accurate, let's say not exact, but a little more accurate, we could say, there's like 19,700,000 people in New York. We could be a little more accurate and round to a lower place value. So we can round a number, we can approximate a number, but we can do so more accurately or less accurately, depending on what sort of information we actually need. And so we're going to need to round to a certain place value. Now here we're given an example. We have the number 23,658. 23,658, and we're asked to round that to the nearest 100. And we're given steps to do this here in the textbook, which makes it very simple. And then further down here, we're actually given a rule for how to round whole numbers. So let's look at how to round whole numbers. First, locate the given place value with an arrow. So if we're told we want to round this number to the nearest 100, mark that place with an arrow. You can see we've marked the hundreds place with an arrow. All digits to the left of that place will not change. Second, underline the digit to the right of the given place value. Underline the digit to the right. And you can see in the example they've underlined the 5, which is the digit to the right of the given place value. Then ask this question: is the digit greater than or equal to 5? If it's equal to or greater than 5, then add 1. So in other words, round up. So anything 5 or greater is going to be rounded up to the next number. So because we have a 6 in the hundreds place and a 5 in the next place, we're going to round the 6 up to 7. Replace all digits to the right of the given place value with zeros. And so you can see the tens place and the ones place have been replaced with zeros. So we took the number 23,658. We marked the place value that we're going to round to, the hundreds place. We then looked at the next value to the right, and we saw that it was 5 or greater. And so we added 1 to the hundreds place and filled the other places to the right with zeros. And so if we want to round 23,658 to the hundreds place, we would round it up to 23,700. Now, if that number to the right was not 5 or greater, you see here it says no. If it was not 5 or greater, then it says do not change the digit in the given place value. So if this was 23,648, we would leave the 6 as 6 and then replace the 5 and the 8 with zeros. But because it's 5 or greater, we add a 1 to the hundreds place. We make the 6 to be a 7, and then we zero out the other digits to the right. So we rounded that number to the hundreds place. That's how we round whole numbers. So you have a good example there to look at. You've got 2 more to try on your own here. And then you've got the rule given in the gray box that teaches you how to round whole numbers. And the steps of this rule were just shown to you as we walked through this example. So there's a summary of the rule. Very helpful, how to round whole numbers. Let's keep moving through this lesson. We're given another example here, example 1.5, and we're asked to round 103,978 to the nearest hundred. So the first thing we want to do is mark the hundreds place with an arrow. We then want to underline the number next to the hundreds place, the tens place. We then want to ask, is this number 5 or greater? And we can see that it is. But this is going to get tricky because we're going to replace this 9 with a 10. So what we've got to do is actually add a 1 to the thousands place and replace the 9 with a 0. So we've got to add 10 hundreds, which is the same as 1,000. So to round to the hundreds place, in this case, we're actually going to go up to 104,000. Make sure you understand why we did that. So even though we've got zeros in 3 places, we're actually rounding to the hundreds place. But because this number was 9, it rounded up to 10, which added a number to the thousands place. So 104,000 is 103,978 rounded to the nearest hundred. And then we go through some more examples, but I'm going to leave that off for now. If that's simple for you, great. Let these exercises test your understanding. And if you have any trouble with that, feel free to get in touch and ask for some help. We can walk through a couple problems together. So that's the end of that section. Now we see the next section begins here with this title, Identify Multiples and Apply Divisibility Tests. This was the second objective back at the beginning of the lesson, to identify multiples and apply divisibility tests. Let's go ahead and read through this. The numbers 2, 4, 6, 8, 10, and 12 all have something in common. If you look at them, they're all called multiples of 2. The reason why they're called multiples of 2 is because they're all numbers that are produced by multiplying 2. 2 is equal to 2 times 1, 4 is equal to 2 times 2, 6 is equal to 2 times 3, 8 is 2 times 4, 10 is 2 times 5, 12 is 2 times 6. These numbers are all multiples of 2. A multiple of 2 can be written as the product of 2 and a counting number. So you see that written out here. 2 is equal to 2 times 1, 4 is equal to 2 times 2, and so on. Make sure you understand that that dot is used as a sign for multiplication. Similarly, a multiple of 3 would be the product of any counting number and 3. So 3 times 1 is equal to 3. 6 is also a multiple of 3, 3 times 2. 9 is a multiple of 3, 3 times 3. 12 is a multiple of 3, 3 times 4. Notice that 12 is a multiple of 3, but it's also a multiple of 2. The same is true of 6. 6 is a multiple of 3, but it's also a multiple of 2. So a number can be multiple of more than one number. But these are multiples. That means that they can be divided cleanly by a common number. Now this table here shows us the multiples of 2 through 9 for the first counting number. So it's just a summary of the multiples of 2 all the way up through 12, multiples of 3, multiples of 4, and so on. So this is just a helpful table. This is not something you need to memorize. It just lists for you the multiples of these different numbers all the way up to 10. Okay, so that's just a helpful chart that's given here. Here in this gray box, we have the definition of a multiple, which is important. A number is a multiple of n if it is the product of a counting number and n. A number is a multiple of n if it is the product of a counting number and n. And this letter n can stand in the place of any number. So a number is a multiple of 3 if it is the product of a counting number and 3. A number is a multiple of 5 if it is the product of a counting number and 5. So n just stands in the place of any number. You can fill any number into that definition and it will be true. A number is a multiple of n if it is the product of a counting number and n. Another way to say that 15 is a multiple of 3 is to say that 15 is divisible by 3. So saying that 15 is divisible by 3 is the same thing as to say 15 is a multiple of 3. This means that when we divide 15 by 3, we get a counting number. In fact, 15 divided by 3 is 5. So 15 is 5 times 3. 15 is a multiple of 3. 15 is also divisible by 3. And we have that clarified here as a definition. If a number m, if a certain number, if any number m is a multiple of n, then m is divisible by n. Now you can notice that these letters are being used in place of numbers. That's actually an important part of algebra, and you can see why that's being done. It's being done because using these letters as symbols of many different possible numbers, it allows us to make a general rule that applies to all numbers. And that study of the general rules of mathematics is really what algebra is all about. So if you want to know how does algebra help us, here's actually a good example. It allows us to create general rules by using letters to represent many different numbers. If a number, and let's just say that number is signified by the letter m, you can fill in any number. If a number is a multiple of another number, then that number is also divisible by that second number. So we can fill in, let's say, 15 for m and 3 for n. The number 15 is a multiple of 3, so 15 is divisible by 3. You can see how the letter is used to represent any number that makes the rule true. We're then told to look at the multiples in table 1.1. Look at the multiples of 5. So if we go back up here, here's table 1.1. we look at the multiples of 5, and we can see them listed here. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. These are the multiples of 5. You'll notice that this is what we mean when we say count by fives. Count to 100 by fives. 5, 10, 15, 20. When we say count by fives, we mean list all the multiples of 5. So we can see the multiples here. All the multiples of 5. Look at the multiples of 5. They all end in 5 or 0. Numbers with the last digit of 5 or 0 are divisible by 5. So what we're told here is just a little trick. Sorry, I didn't want to make that arrow. We're taught here a little trick how to determine if a number is divisible by 5 or if a number is a multiple of 5. All of the multiples of 5 end in 5 or 0, 5 or 0, 5 or 0. So any number that ends in a 5 or a 0 is a multiple of 5. And we're asked to look if there are any more patterns, and then they're actually given to us down here. So this is a helpful little summary of divisibility tests. You can memorize these and easily be able to identify the multiples of a number, or to determine if a number is divisible by another number. If the last digit is 0, 2, 4, 6, or 8, then that number is divisible by 2. If the sum of the digits, so if you actually add all the digits, and that number, the sum, is divisible by 3, then that number is divisible by 3. What does that mean? Let's check that out. Let's look up here at the multiples of 3. If we look at the number 12, if we add the digits together, 1 and 2, 1 and 2 make 3. 3 is divisible by 3, therefore 12 is divisible by 3. If we look at the number 27, we see 2 and 7. If we add those digits, 2 and 7 makes 9. 9 is divisible by 3, therefore 27 must be divisible by 3. If we look at 36, 3 plus 6 makes 9. Again, 9 is divisible by 3, so 36 must be divisible by 3. So this is just a helpful list of some divisibility tests, way to determine if one number, especially a large number, is divisible by any other number. We can use these little tricks or tests to help us figure that out. And then down here, you're given a number, 5,625, and you're asked, is this divisible by 2? If we look at our divisibility tests, a number is divisible by 2 if the last digit is 0, 2, 4, 6, or 8. Well, the number 5,265, the last digit is not 0, 2, 4, 6, or 8. So this number is not divisible by 2, and we see that we're right here. The answer is no. Next, is 5,625 divisible by 3? Now, if we didn't know this helpful divisibility test, that would be very difficult to figure out. We'd have to actually divide the numbers and see if it's divisible. But our rule tells us that if we just add the sum of the digits, so 5 and 6 makes 11, 11 and 2 makes 13, and then 5 makes 18, 18 is divisible by 3. So 5,625 is divisible by 3. And we can see down here that our answer is right. So we answered that question there not by actually dividing, but we answered that question by using this helpful divisibility test. And so you can continue to use those tests on other examples, but I'm going to leave you to do that on your own. We've got about 5 minutes left, and I'd like to try to finish this lesson in one video. The last part, this is the third objective for this lesson, for section 1.1. The third was to be able to find prime factorizations and least common multiples. Now there's a lot of fancy language here. Prime factorizations and least common multiples. So we're going to have to figure out this vocabulary to understand what this is even talking about. So let's go ahead and read here. In mathematics, there are several ways to talk about the same ideas. So far, we've seen that if a number m is a multiple of a number n, then we can say that m is divisible by n. So there are several different ways to talk about the same idea. We can say that m is a multiple of n, and to make that clearer, we could say that 15 is a multiple of 3, but we can express the same idea by saying that 15 is divisible by 3. And we're given an example here with 72. We can express this same idea in still another way. We can express this in another way. Since 8 times 9 equals 72, we can say that 8 and 9 are the factors of 72. Now, it's helpful to know that the word factum in Latin means made. 8 and 9 are the numbers which make 72 by multiplication. 8 and 9 make 72 in multiplication. When we write 72 equals 8 times 9, we say that we have factored 72. So to factor a number means to find the numbers that can be multiplied together to produce or make that number. The numbers that are multiplied are called factors, and when they're multiplied, they make that number. It's called the product. That's what they make. They make the product. So when we write 72 is equal to 8 times 9, we say that we have factored 72. And we can do this in a number of different ways because 72 can be produced by a number of different factors. For example, 1 times 72 makes 72. 2 times 36 makes 72. 3 times 24 makes 72. 4 times 18 makes 72. And 6 times 12 makes 72. So we can factor 72 in a number of different ways. There are many factors of 72, and you've got a whole list of them here. So we can factor 72 in a number of different ways. And that leads us to this definition here, or rule. If the expression a times b, where a and b can represent any numbers, in the expression a times b, a and b are called factors. If a times b equals m, and both a and b are integers. Now, I don't think that the textbook explained what an integer is. The word integer comes from the Latin word integer, which just means whole. So an integer is simply a whole number. If a times b equals m, and both a and b are integers, or whole numbers, then a and b are factors of m. If a times b equals m, and a and b are both integers or whole numbers, then a and b are factors of the product m. Some numbers, like 72, have many factors. Other numbers have only 2 factors. And make sure you pay attention to this second sentence here. Some numbers, like 72, have many factors. Other numbers have only 2 factors. Some numbers have only 2 factors. Now let's learn about prime and composite, because we saw prime factorization. So we have to ask, what does this word prime mean? We understand what factor means now, what factoring means. It means finding the numbers that, when multiplied, produce a certain number. So we know what factor means. But what does prime mean? A prime number is a counting number greater than 1 whose only factors are 1 and itself. A prime number is a counting number greater than 1 whose only factors are 1 and itself. So for example, the number 3 is a prime number. It's a number greater than 1, and its only factors are 1 and itself. 1 times 3 makes 3. There's no other factors for 3. Another prime number could be 5 or 7. The only numbers that produce 7 by multiplication are the numbers 1 and 7 itself. So a prime number is a counting number greater than 1 whose only factors are 1 and itself. Now notice that based on this definition, 1 is not a prime number. Based on this definition, 1 would not be a prime number because it says a counting number greater than 1. So the first prime number would be 3, a counting number greater than 1 whose only factors are 1 and itself. A composite number is any number that's not a prime number. A composite number is a counting number that is not prime. A composite number has factors other than 1 and itself. So 72 is an example of a composite number. It has other factors, not just 1 and itself. 72 is a composite number. 7 is a prime number. The counting numbers from 2 to 19 are listed in figure 1.5 with their factors. Make sure to agree with the prime or composite label for each. So if we look at these numbers and list their factors, so the number 2 can only be produced by 1 and 2. It's actually the first prime number. I think I might have said 3 before, but 2 is the first prime number, obviously. The only factors for 2 are the number 1 and itself, so it's prime. 3 also, the only factors are 1 and itself, so it's prime. The number 4, however, can be made by 1 and itself. 1 times 4 makes 4. But 2 times 2 also makes 4. So 2 is a factor of 4. So 4 is a composite number. And you can continue moving through the numbers all the way up to 19 and test yourself. Look at the number and ask yourself, is it prime or composite? And check your answer here in the table. All right, so use this table to check and see if you understand what prime and composite numbers are and whether you can identify a number as a prime number or a composite number. The prime numbers less than 20, if we just summarize what's in this table, the prime numbers less than 20 are 2, 3, 5, 7, 11, 13, 17, and 19. Notice that the only even prime number is 2, and an even number is a number that can be divided by 2. The only even prime number is 2. Now, if we look back at the topic here, the topic was prime factorization. So what in the world does prime factorization mean? That's what we have down here. A composite number can be written as a unique product of prime numbers. A composite number can be written as a unique product of prime numbers. This is called prime factorization. So this is what this idea means. Prime factorization. Remember before I said you might want to jot down terms that are printed in bold because they're important vocabulary items. And you see prime factorization defined here in this colored box. The prime factorization of a number is the product of prime numbers that equals the number. These prime numbers are called the prime factors. So we can find factors for any number, but this is a unique challenge. We want to find the prime numbers that produce a certain number. So let's look at an example. Let's look at the number 48. 48 is a composite number. We want to find the prime factors. So what we do is we just start listing the factors. And here you can see 48 is equal to 2 times 24. 48 is equal to 2 times 24. So we're making something that looks like a tree. 48's on the top, and we write the factors, 2 and 24. Now we notice that 2 is a prime number, so we circle it. And we've got 24 as the other factor. So now what we're going to do is think of what are the factors of 24. 24 is equal to 4 times 6. 24 is equal to 4 times 6. So now we have 24 and we write 4 times 6 underneath it, and we look at that factor and we ask, what are the factors of 4? The factors of 4 are 2 times 2. And both of these factors are prime. The factors of 6 are 2 and 3. And both of these factors are prime. So what we've done is we've used this tree, and you should look just this section right here. Starting from 48, we broke it down into its factors. 2 was prime and 24 was composite. So we broke 24 down into its factors. 4 is composite and 6 is composite. So we broke 4 down into its factors, and we found that 4 has 2 prime numbers for its factors, and 6 also has 2 prime numbers for its factors. So if we look at this whole tree here, this is called prime factorization. We've got 1, 2, 3, 4, 5 numbers circled. Those numbers, if we multiply them all together, they make 48. And they're all prime numbers. So this is called the prime factorization of 48. 48 is equal to 2 times 2 times 2 times 2 times 3. These are the prime numbers that are factors of 48. So we can identify the number 48 by its prime factors. This process here is called prime factorization. Prime factorization. Finding the prime factors of a composite number. So we see how to do that. You've got a couple examples to work on here, and we've got a summary down here of the rule. How to find the prime factorization of a composite number. How to find the prime factors of a composite number. Now, again, you can ask, why would I ever need to do this? Why would I need to do this? And remember, there's a simple answer for that question in algebra, because this course is required for our high school diploma. If that answer is good enough for you, then just be content with that answer and work to learn all of these lessons. We can find the prime factorization of a composite number by these steps. And these steps were shown here in this chart as we worked to find the prime factors of 48. So that's prime factorization. And that we have a a solution for a more difficult number, 252. But you see the process is the same. We just think of the factors and then continue to break those factors down until we're left with just prime factors. So that brings us through prime factorization. And the last issue we're going to deal with, I think we're close to the end here. Let me just scan down and see if we're getting close to the end here. Yeah, we see the section exercises. We're almost done here. Let's just keep going here. Now, I said to you that if someone asked you the question, why would we ever need to find the prime factors of a number? I told you a good answer is just, it's required in algebra, and algebra is required for my high school diploma. That would be a good answer. But here we actually can learn of a good answer for that question, why prime factorization is actually helpful. We read, one of the reasons we look at multiples and primes is to use these techniques to find the least or the lowest common multiple of two different numbers. So we can use prime factorization to help us find the least common multiple, the lowest common multiple shared by two different numbers. And you may ask, why do I need to know that? We'll learn later why we need to do that, because it's useful. But remember, it's good enough to say we need to learn this because we need to learn algebra, because we need to earn our high school diploma. But we'll see later why finding common multiples and the least common multiple is important. But for now, we're going to learn how to do that, how to find least common multiple of two different numbers. The first method is by listing multiples. So we can simply list the multiples of two different numbers, and then we can find what multiples they have in common. So for example, if we take the numbers 12 and 18, and we list their multiples, so 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, and so on up through 108, which is 12 times 9. We have a list of multiples of 12. We can do the same thing for 18. We can list 18 times 1 is 18, 18 times 2 is 36, 18 times 3 is 54, and so on again up to 108. If we simply list the multiples for 12 and 18, we'll see that that list has some numbers in common. 36 is a common multiple, 72 is a common multiple, 108 is a common multiple, and there will be other common multiples if we continue. But we can see a few common multiples, and they're listed here. The common multiples of 12 and 18 are 36, 72, and 108. So if we want to find the lowest common multiple, we simply look at the lowest number in that list of common multiples. So this is called the listing multiples method to find the lowest common multiple. We can simply list the multiples, find the common multiples between the two numbers, and then look to see which common multiple is the least or the lowest. That would be the lowest common multiple, and you see we use the abbreviation LCM for least or lowest common multiple. So you should understand what multiples are, you should understand what common multiples are, and you should understand what least common multiple means. The least common multiple, or LCM, of two numbers is the smallest number that is a multiple of both numbers. The least common multiple of two numbers is the smallest number that is a multiple of both numbers. And here you've got a summary of the rule to find the least common multiple by listing multiples. Listing multiples, as we saw up here. And you're given an example or exercise You're asked to find the lowest common multiple of 15 and 20 by listing multiples. Find the lowest common multiple of 15 and 20 by listing multiples, and you're shown again how to do that here and given a couple more examples down here. Now here we learn that there's another method for finding the least common multiple. The second method to find the least common multiple is to use the prime factors method. Let's find the lowest common multiple of 12 and 18 again, but this time we'll use the second method. We'll use their prime factors to find the least common multiple. So the first thing that we're going to have to do is we're going to have to write out the prime factors of 18 and 12. And you can see we do that here. So we find the prime factors of 18 are 3, 2, and 3. And we find that the prime factors of 12 are 3, 2, and 2. So we've got the prime factors of 18 and the prime factors of 12 written out. Now, step 2 says list the primes of each number. List the primes of each number. Match the primes vertically when possible. So if the two primes are the same, you should list one right above the other. So list the primes. List the primes of 12. We see 2 times 2 times 3. List the primes of 18. We see 2 times, and then we see 3 listed under the other 3, and the other 3 added at the end. So the primes of 12 are 2, 2, and 3. The prime factors of 18 are 2, 3, and 3. And you can see how they listed them so the numbers line up if possible. Step 3 says bring down the number from each column. Bring down the number from each column. So after lining them up in this way, we're simply going to bring down that number that's in each column. So we're going to bring down a 2, bring down another 2, bring down the 3, and bring down another 3. And we're told here that the product of those prime numbers, is the lowest common multiple of 18 and 12. So the lowest common multiple of 18 and 12 is 36. That's the same answer we found above when we listed them. We found that the lowest common multiple is 36. We did that with the listing multiples method, and now down here we found the same answer using the prime factors method. So 2 different methods to find the least common multiple. Notice the prime factors of 12 and the prime factors of 18 are included in the lowest or least common multiple. 36 is the least common multiple of 12 and 18. By matching up the common primes, each common prime factor was used only once. This way you are sure that 36 is the least common multiple. Now, I'm sure after you learn this, you may be asking, well, how does that work? Okay, I understand that this is a rule, and I'm being taught that this is a method for finding the prime factors. But how do I know that actually works? Why does this actually work? That's a good question to ask, and unfortunately, the textbook doesn't do a very good job explaining why this rule actually works. This is one of the things that frustrates modern math students. You're taught this rule, but you really don't understand how it works. So a good challenge for you is to explain why this rule, why the prime factors method actually allows us to find the least common multiple. I encourage you to try to answer that question. You can post your answer on the forum for the course page, but see if you can answer that question. Why does this method, using prime factors, allow us to find the least common multiple? The book doesn't give us an answer to that important question. Let's see if we can figure that answer out ourselves. All right? Moving on, we've got another example. Find the least common multiple of 24 and 36 using the prime factors method, and you see that done here. We're shown that the least common multiple of 24 and 36 is 72, so you can test your understanding with that example, and then try these two challenges and see if you can find the right answer for the least common multiple for these pairs of numbers. Okay? Now, that brings us to the end here. We see the Section 1.1 exercises. Section 1.1 exercises. So you should work through these exercises and use them to test yourself. We'll also provide a test at the end of the chapter to make sure you understand. So I would recommend that you take time and work through these exercises. Make sure everything looks simple. See that you feel confident about your understanding. Use it to help you also review the lesson. But work through those exercises. Everyday math gives you some examples that we might say could be a part of everyday life where we see how this could be useful. Sometimes these are not going to be very useful at all, like writing a check or remodeling a kitchen. You're probably not going to remodel a kitchen anytime soon, but it gives you some examples of how this arithmetic is used, and then some writing exercises to help you think through and explain the math that we're learning. Now, this self-check section of the lesson is important. It asks you to look back at the objectives that were given at the beginning of the section. We were given 3 objectives: to use place value with whole numbers, to identify multiples and apply divisibility tests, and to find prime factorizations and least common multiples. And you're asked to check how you feel about your progress after studying the lesson. Now, obviously, after simply watching this video, you might understand a little more than you did before, but I would recommend that you review this video, review your textbook, work through the exercises, study the definitions of the terms that we learned, study the rules that we learned in this lesson, and then answer this self-check question. And hopefully, you'll be confident that you understand and have achieved each of these 3 objectives. That's the goal for Section 1. And with that, we're going to end this video. Now, you can see this was a long video, 1 hour and 23 minutes, but that counts as 1 hour and 23 minutes, over an hour, almost 1 hour and a half of the 120 hours of instructional time that you need for algebra. So if you worked through this video with me and put in that 1 hour and 20 minutes, you've picked up 1 hour and 20 minutes, almost 1.5 hours of instructional time. And we're going to continue that until we finish our required number of 120 hours. So I'll continue producing these videos. You continue working through these videos to complete your instructional time. Then on your own time, work through the exercises, study the lessons, and we'll move through this course together and get Algebra I finished. Remember, if you need motivation for studying Algebra I, it's very simple. We need to study Algebra I because it's required for a high school diploma. That can be a good enough answer to that question to motivate you to study and get this done. So work on this first section, Chapter 1, Section 1, and we'll continue into Section 2 in our next video. I hope that's helpful. God bless your studies.